Alright, I want to look at solving a system of linear equations by graphing. Okay, and we've already looked at using elimination, using substitution, and so now I want to do graphing. And again, I'm going to use the same example so we see that we get the same answer. And so I used in the first equation was y equals x plus 2. So we need to graph that. And then the other equation was y equals negative 2x plus 5. So we're solving by graphing. So we need to graph both of these and see where they intersect. That'll be our solution. So let's go ahead and do the first one here. Y equals x plus 2. And to graph that, we need to know, well, let's just backtrack just a little bit. The general form of this, this y-intercept form is y equals mx plus b. Okay, y equals mx plus b. And the m here, that is our slope. Okay, our slope, or our rise over run. Okay, and then the b here, the b, that is our y-intercept of the equation. It's our y-intercept. Okay, so when it's in this form, y equals mx plus b, this is what we have. We have the slope, we have the y-intercept. So in both of these cases, we have the slope right here. Well, there's no number written in here in front of the x. So it's an implied 1, or in this case, you know, if we want to think of it as rise over run, we could write it as 1 over 1, because 1 over 1 is 1. And there's an implied 1 in front of that x, so that's our slope. Okay, so, and then the y-intercept of this first equation, well, it's b, and b is 2, so it's at 2. Okay, so the first thing we want to go ahead and do is graph the point 0, 2, or the y-intercept. It's 2 right here. Okay, let me do that. I'm going to actually do that in yellow here. So there it is. There's our point. Okay, at 2. And then we want to go ahead and count up and over, you know, up 1 and over 1, positive, that's a positive slope, so up 1 and over 1 unit, and that point should lie on the line. Problem is if you're using a straight edge and ruler on a piece of paper, that's not real accurate. They're so close together. So I would just count up. You can still count up 1 again, and over 1, and up 1, and over 1, and you can keep doing that. So we've done it 1, 2, 3 times, so 1, 2, 3, so it should be about there. On your graph paper, it'll be a little, I went backwards here a little, shouldn't it? Up 1 and over 1. Okay, so right there is another good point, right there, and that's this blue line. Okay, and on graph paper, you'll be able to count that real easy. Okay, so let's go ahead and draw in that line. Now, you'll want on a piece of paper, you want to use a ruler here, draw through with a ruler. We want a nice, accurate graph, and so mine won't be really crazy accurate, but it'll be all right. So it's supposed to be going through this point right here, going through that point, and there's our line right there. That's this line. Okay. Okay, so we got that graphed. So now what we want to do is we want to go ahead and graph this green line, this one here, and see where they intersect. And so, same thing. We want to graph this y-intercept, and the y-intercept's at 5. It's at 5. So it's right here. And again, I'm going to go ahead and I'm going to use a different color. I'll use pink. And I'm going to graph at 5. A point. That's a point on this line. In fact, it's the y-intercept. It's right here. Okay. Now, our rise over run, or our slope here, it says negative 2. But since it's not a fraction, we can kind of make it a fraction by putting a 1 over it. So, in other words, so our m, our slope, is negative 2 over 1. Well, that really equals negative 2 over 1 positive, or it equals 2 over negative 1. So either way, so now we have the 2 positive and the 1 negative, or the 2 negative and the 1 positive. These are all equal. These things are all equal. Okay, so you want to look at the form here or here that works best for you. And since this is an up 2 and to the left 1, we don't want to use that because there's no up 2. We don't have a graph here that can go up 2. So we want to use the down 2 and to the right 1. So this is going to go count down 2, 1, 2, and to the right 1. And you can see that's our point of intersection right there. That's our point of it. See, it landed right on this point that's on the line of this blue line. That's our point. But we can get a further point to have a more accurate line anyway. So we can go down 1, 2 again, and over 1 more time. That's not too bad. And so there's another point on the line. Put this in green. And we can draw a line with a ruler, if you have a ruler, through that point, through those 2 points. Real nice and accurate. Now mine isn't super accurate because it's hard for me to put a ruler here on the computer, but you kind of get the gist of it. But this point right here is our point of intersection, and we can see that by counting 1, 2, and over 1. Right there, it landed right on that point. And that's so that's right here, that's over 1 and up 1, 2, 3. Okay, so it's right here. So it's the coordinate point 1 over 1 and up. You can see 1, 2, 3, up 3, and there's our answer. 1, 3, and we just solved that by graphing. And of course, this will be a lot nicer on a piece of graph paper, doing it at home or in class. But there you go, 1, 3, there's our answer. So our final answer is the coordinate point 1, 3, or x equals 1, y equals 3. Okay, either way is good. You box around it and you're done. Alright, thank you for watching the video.